Hi everyone, so today we're going to start a new unit, and this unit is all about proofs. So proofs in math are something, there's several different kinds of proofs, but basically what it means is that we are going to prove that the math works, or that one thing is equal to the other, or that one thing is not equal to the other. A lot of the times when we talk about proofs, it'll say, knowing that this is a triangle, prove that it's a right triangle, or knowing that these are the two end points of a line, prove this line has a slope of 4, or things like that. And so while the wording is a little bit tricky, it actually is a lot of this stuff is actually pretty easy because it's just what we've already learned, but in a little bit of a different way. So for this video, we're going to be talking about slope proofs, and particularly about parallel and perpendicular lines. So let's just go over a couple of key phrases about parallel and perpendicular lines first. And just so you're aware, this is all on your key term sheet as well. So parallel lines are lines that have the same slope, and they look exactly the same. So they're kind of like this. The first thing to know is that they will never ever intersect. And this is because they have the same slope. So same slope. So if something has the same slope, that means that it rises and moves forward or towards the right at the same rate that another line does, which means that they will never ever intersect. They will always stay the same distance apart. So same distance apart. Okay, so those are parallel lines. Now perpendicular lines are more like this, where one intersects the other, and they intersect each other at a 90-degree angle. So for perpendicular lines, we know that they always will intersect. We know that they intersect at a 90-degree angle. And that just means that they cut each other right, not necessarily right in half, but one's not tilted more than the other. Each of the four corners that it creates are all 90 degrees. And because of this, we know that if one line has a slope of m, then the other has a slope of -1 over m. These are called negative reciprocal slopes. A good example of them, like without using a formula, would be like if I knew one line had a slope of 2/3, in order to have a perpendicular slope, the other line would have to be -3 over 2. So basically I flip-flop the fraction and I make it negative, or I change the sign. If the fraction already was negative and then I wanted a negative reciprocal, the new fraction would be positive. So these are parallel and perpendicular lines. The other thing that we want, let's go through this really fast. The other thing that we want to know for this is the slope formula, which we've already gone over, but I'm just going to write it down again. The slope formula is m is equal to y2 minus y1 over x2 minus x1. And this is if I have 2 points where it's like x1 comma y1 and x2 comma y2. And these will be helpful on the examples 3 and 4. So for this self-check, I'm going to be asking you a couple of vocabulary questions, but I'm also going to ask you to prove that lines are parallel or prove that lines are perpendicular. And in order to do that, we're just going to use the slope formula. So let's go through some of the vocabulary questions first. The first example, what we're going to do for the first two examples, we have to fill in the blank, and we're going to fill in the blank with either sometimes, always, or never. So number 1 says, if two lines intersect, then they are blank parallel. Well, based on what we just wrote up here, parallel lines never intersect. So if two lines intersect, then they must never be parallel. So they are never parallel. All right, now let's look at the second question. It says, if two lines have negative reciprocal slopes, then they are blank perpendicular. So are they sometimes perpendicular, never perpendicular, always perpendicular? Well, we just agreed that those slopes, like these examples that I wrote up here at the top, are negative reciprocals and they represent perpendicular lines. So in this case, if two lines have negative reciprocal slopes, then they are always perpendicular. All right, so now let's get down to the next two examples where we're actually going to prove if things are parallel, perpendicular, or neither. So we know that for parallel lines, they have to have the same slope, and perpendicular lines have to have negative reciprocal slopes, and sometimes you don't get either of them. So sometimes you could have just two random slopes that aren't the same but aren't negative reciprocals. That would be that we know that they're intersecting, but they're not intersecting in a 90-degree angle, so they're not perpendicular and they're not parallel, so they're neither. So in order to prove this, for examples 3 and 4, what we're going to do is determine whether they're parallel, perpendicular, or neither. And in order to do this, what we're going to do is find the slope between each set of points. So you have two lines, L1 and L2, and we know that they cross through two different points. So I'm going to start with L1. And we're going to use the slope formula, which again is m is equal to y2 minus y1 over x2 minus x1. And let me get out a different color here. For L1's case, it would be x1, y1, x2, y2. The only reason I say x1, y1 on the first one and x2, y2 on the second one is because one's first and one's second. I could flip-flop that, but it's easier just to keep it in order. All right, so then let's plug in that information. So I'm going to have m is equal to y2, which is 6, minus y1, which is 3, over x2, which is 5, minus x1, which is negative 1. So when I have a negative number that I'm plugging into the formula, I always put it in parentheses. The only reason I do that is because I don't want to get mixed up with the negative and the minus sign. And because I don't want to, I want to make sure that I change the sign accordingly. So whenever you're putting negative numbers in, just always put them in parentheses. Okay, so now let's simplify that. On the top, we have 6 minus 3, which gives me 3. And then on the bottom, when we have two negative signs right next to each other, it becomes a big plus. So on the bottom, we have 5 plus 1, which gives me 6. So 3 over 6. Simplified, if I divide both of those things by 3, I get 1 over 2. So my slope of L1 is 1 over 2. All right, now let's look at the second line, so L2. And once again, we're going to use the slope formula. I won't rewrite it, but, and let me use a different color again. We would have x1, y1, x2, y2 again, and we're going to plug in what we know to the formula. So we start with y2, which is 4, minus y1, which is 1, over x2, which is 0, minus x1, which is negative 6. We plug that in inside parentheses. Now let's simplify that. On the top, we have 4 minus 1, which gives me 3. And on the bottom, I have 0 minus 6, or sorry, remember, two negatives make a big positive. So now I have 0 plus 6, which gives me 6. I can divide both the top and the bottom by 3, which gives me 1/2. So slope of line 1 was 1/2, slope of line 2 is 1/2. They are the exact same slope, which means that these two lines have to be parallel. So that's my answer. And we proved that they're parallel because they have the same slope. All right, now let's go and do the same thing here. So we're going to start with line 1 or L1. And we're going to use, again, the slope formula, which is m is equal to y2 minus y1 over x2 minus x1. And now let's label. We have x1, y1, x2, y2. And remember, we're trying to decide if these two lines have parallel slopes, perpendicular slopes, or neither of those options. So first we have to find the slopes of each. So let's plug in what we know. We're going to have m is equal to my y2, which is 3, minus y1, which is 9, over x2, which is 4, minus x1, which is 2. Okay, so on the top we have 3 minus 9, which gives us negative 6. And on the bottom we have 4 minus 2, which is 2. When I simplify that, negative 6 divided by 2 gives me a negative 3. So my slope of the first line is negative 3. Now let's go to L2. And I won't write the slope formula down again, but let's label our points. We have x1, y1, x2, y2. And now let's plug it in. So I'm going to have m is equal to, we start with y2, which is negative 2. I'm going to put it in parentheses because it's negative, minus y1, which is 1, over x2, which is negative 6, minus x1, which is negative 5. Now let's simplify this. On the top, we have negative 2 minus 1, which gives me a negative 3. And then on the bottom, we have two negatives right next to each other, which makes a big plus. So we have negative 6 plus 5, which gives me a negative 1. When I simplify that, I get negative 3 divided by negative 1. A negative divided by a negative is a positive, so this is just a positive 3. So now I have one line that has a slope of negative 3 and one line that has a slope of positive 3. Now, on your paper, you have a graph that you can graph both of these things on, and you're more than welcome to do that. It's not necessary, but let me show you. If I had a slope of 3, I'm going to just start each of them at 0, 0. I know that the points are different, but just so that you can see. If I have a slope of positive 3, it would go up 3 over 1 or down 3 backwards 1. So it would make a line that kind of looks like this. Now, if I have a slope of negative 3, I would go up 3 and backwards 1 or down 3 and right 1, which gives me a slope that kind of looks like this. Now, they're opposites of each other for sure, and they make a really pretty X, but these are not parallel because they do intersect, and they're not perpendicular because even though they intersect, they should be they want to be intersecting at a 90-degree angle in order for it to be perpendicular, and this isn't a 90-degree angle. This is more like a 30-degree angle or something close to that. So because these two are not, we know they don't have the same slope, and we also know that they don't have negative reciprocal slopes, then my answer in this case would be neither, that they have neither parallel nor perpendicular slope. And once again, we did that because we proved that they didn't have a parallel or perpendicular slope because we found the slopes of each. Potentially we could write a proof. So that's one thing that we can do in math is write a proof that says something along the lines of, because the slope of L1 is negative 3 and the slope of L2 is 3, these two lines are neither perpendicular nor parallel. It's very formal, and we're not going to get too much into the formality of these proofs this year, but this is how we prove parallel and perpendicular slopes.